Good evening, sir.
Good evening, Ajay. Okay. Ajay, in the last class, we have studied the concept of lateral shift, right?
Yes, sir.
Okay. Today, we learn the two more concepts, that is normal shift and the total internal reflection. After learning these two concepts, we'll take the problems on all these concepts of refraction. Okay.
Yes, sir.
Yeah. Yeah. Okay. Now we'll talk about the concept of what? Normal shift. Now look at this diagram. If I considered one parallel sided glass slab, okay.
Yes, sir.
Here also I'm going to place one parallel sided glass slab. Now, let us say this is rarer medium. This is denser medium. This is rarer medium. This is denser medium. Now, I'm going to place the object here. This is the object. Okay. Here I'm going to place the object. What is the difference?
So in the first one, the object is in the medium, sir, in the denser medium, and the second one is in the rarer medium.
Yeah. Now the observer is somewhere here. This is observer. Okay. This is observer. Observer. Yeah. Now, from the object, if I take the ray of light like this is the normal, no refraction apart. Okay. At this particular point, can you tell me the refracted ray will bend towards the normal or away from the normal?
Sir, it will bend away from the normal, sir, because it's going from denser to rarer.
Yeah, it bends away from the normal. So this is called the angle of refraction. This is called the angle of incidence I. Now, if I take this ray, refracted ray backward, it will meet the normal at this point, which is the virtual image. It is not a real image, appa, it is a virtual image. Why it is virtual image?
Sir, because initially the image, sir, because the image is formed. So the light rays are drawn back to get the image, sir.
Yeah. Actually, in the case of a refraction, refracted ray will be in the other medium. No. Actually, the object is in first medium. Image has to be formed in the second medium. Actually, this is real image. But observer is viewing normally here. So he is first get the virtual image of this object. Correct? No.
Yes, sir.
So there is a little bit rise in the object along the normal. There is a little bit rise in the object along the normal. How much of rise is there in the object along the normal? That shift is what we call.
So normal, sir.
Yeah, normal shift. Normal shift. Now, from ear to ear, it is called the real depth. RD, real depth. From the surface to the image, this is called the apparent depth. So what is real depth, my dear? Real depth is the distance of the object from the actual surface, right?
Yes, sir.
The distance of the image from the surface is called the apparent depth. Now, please remember, refractive index is always equal to real depth by the apparent depth. What is the refractive index formula for this case? Real depth
So
by
real depth by apparent depth.
Real depth by apparent depth. Then, can you tell me what is normal shift?
So normal shift will be real depth minus the apparent depth, sir.
Real depth minus the apparent depth. Also, please remember this normal shift is also given by the formula T into 1 minus 1 by N. T into 1 minus 1 by N, where T is the thickness of this slab. T is the thickness of this slab. N is the refractive index of the denser medium and rarer medium air. If the observer is in air medium, then what is the normal shift formula? T
So
into T into 1 minus 1 by N. What is T actually?
so the thickness of the denser medium, sir.
Yeah, the thickness of that slab, or that thickness is also equal to real depth. That is
Yes,
also equal to what?
So real depth.
Real depth. So real depth minus apparent depth is called as what? Real depth minus apparent
So
depth is
normal
called as
shift.
what?
Normal shift.
One second. Real depth minus apparent depth.
Excuse me, sir. Sir, you are not audible, sir.
Now?
Now you are audible, sir.
Okay, okay. Real depth minus what? Apparent depth. Now, in the case of a second case, this is the rarer medium and this is the denser medium. Where is the object, Appa?
So objects in the rarer medium.
Rarer medium. Now, from the object, if I take the ray like this along the normal, there will be no refraction. There will be no refraction. If I take the ray of light like this is normal, right?
Yes, sir.
Now, the ray of light is passing from where to where? Rarer to.
So from rarer to the denser medium.
So the refracted ray should bend towards the normal, right?
Towards the normal, sir.
Yeah. So if I extend this backward, I'm going to get the image somewhere here. This is real image or virtual image?
So virtual image.
Very good. Now there is an apparent shift in the object, right?
Yes, sir.
What is this apparent shift called? Normal shift. So what is normal shift? The shift in the object, no?
Yes, sir.
Yeah. Now, from where to where the real depth is there? From the object to surface, this is real depth. This is apparent depth. Now, what is refractive index for the second case? It is apparent depth by real depth. The normal shift for this case is given by T into n minus 1. N minus 1. Also, normal shift must be equal to real depth minus apparent depth or apparent depth minus real depth. Apparent depth minus real depth. Now, can you tell me the difference between these two cases? Can you tell me the difference between these two? In the first case, real depth is more than what?
So apparent depth, sir, and in the second case, the apparent depth is more than the real depth.
Real depth. Got it? You got it, no?
Yes, sir.
Yeah. Now, this is the basic concept. Now, let me analyze like this. Now, I'm going to consider one beaker appa. This is one beaker, okay? Now, in this beaker, I'm going to fill some fluids, athwa liquids. I'm going to fill, this is the liquid. This is liquid. The refractive index of this liquid is mu1, or you can take it as N1. What is N1? Refractive index of the first liquid. The thickness is D1. Then I'm going to fill the second liquid. The refractive index is N2. The thickness is D2. Now I'm going to fill one more liquid. Refractive index is N3. The thickness is
So D3.
D3. Now my question is, I'm going to place the object here. Okay. This is object. Now, if I look at this object from the rarer medium, now the object should be raised, no? Object should be raised, no? This object should be raised to this particular point. This is the virtual image of that object. Okay.
Yes, sir.
Now, you have to calculate what is the apparent depth. What is the apparent depth? Okay. Second is refractive index of this entire combination. Because it is a combination of three liquids, no. I want what is the refractive index of this combination. This type of concepts will come for NEET exams in MCQs. Can you calculate the apparent depth? Look at this. What is basic definition for refractive index?
So real depth by apparent depth, sir.
N is real depth by apparent depth. Can you tell me what is apparent depth from this?
So real depth by the refractive index.
So what is the total apparent depth? Here, how many liquids are there?
So D3 by F3.
So three liquids will be there. So
Yes,
from
sir.
all the three liquid medium, there will be apparent depth, right?
Yes, sir.
Can you tell me what is the real depth for the first medium?
So
What is the real depth for the first medium? First medium
Sir.
idalveno. This is the first
Yes,
medium,
sir.
right?
So D1 by N1, sir.
Ah, very good. D1 by N1 plus. What is the apparent depth for the second case, second medium?
So D2 by N2, sir. And
Very
third
good.
one is D3 by N3.
D2 by N2 plus D3 by N3. So this is the apparent depth. Okay. Now I want to find what is the refractive index of the combination. How do you define the refractive index? It is real depth by apparent depth of what? Combination, no?
Yes, sir.
What is the real depth of the combination? Total real depth. Total real depth. D1 plus D2
Sir,
plus
D1 plus D2 plus D3, sir.
like that. How many slabs will be there? Or that number of liquids you have to write, right?
Yes, sir.
Yeah. What is apparent depth of the combination? We have here. What is the
Yes,
apparent
sir.
depth of the
So
combination?
D1 by N1 plus
Ah.
D2 by N2 plus D3 by N3, and it goes on.
Yeah, like that. So this is the refractive index of the combination. Okay.
Yes, sir.
Yeah. One more concept related to this, Appa. This. Now, there is one beaker. In this beaker, just I'm going to divide equal off. This is D, this is D. This is filled with N1, this is filled with N2. Can you tell me what is the refractive index of the combination? Can you tell me the refractive index for the combination for this? Tell me what is the refractive
Yes,
index
sir.
of the combination?
D plus D divided by D by N1 plus D by N2.
Yeah. D plus D means 2D, no?
Yes, sir.
In the denominator, you can take out D as common, right?
Yes, sir.
Yeah, you cancel D and D, you take out LCM in the denominator and you simplify. Tell me the final value. You want me to solve?
No, sir. Solve.
Okay, please solve it. D plus D in the numerator. In the denominator, it is D by N1 plus D by N2.
So 2 N1 N2 by N1 plus N2, sir.
Very good, very good. 2N1 N2 by N1 plus N2. Please remember this shortcut formula, because this shortcut formula will help you out. If the two equal thickness liquids are filled with the different refractive index N1 and N2, they may ask you to calculate the refractive index of the combination. What is the refractive index of the combination? Two
So
times
2
of
N1,
N1 N2
2
by
N1 N2 by N1 plus N2, sir.
N1 plus N2. You got the concept right about normal shift.
Yes, sir.
Please remember all these formulas. These are the quite important formulas. 1, 2, 3, 4. This total apparent depth. total combination, and this shortcut formula. This are the important formulas. You have to highlight it. Correct? No?
Yes, sir.
Yeah. So let me take up the next concept. This is also very important, Tappa. For your board exam, they will ask, I mean, for your competitive, there will be one problem based on total internal reflection also. Total internal reflection. Yeah. Look at this. I'll keep one interface. This is rarer medium. This is denser medium. Okay. Now I'll write this is the normal ray. If I incident the ray of light at one particular angle called critical angle, remember this critical angle, the ray will grazes like this. What is this angle equal to? What is that angle equal to?
Angle, so 90 degrees.
90 degree. That angle we call it as a critical angle. So what is critical angle? Critical angle is the
angle. So it's the angle in the denser angle of incidence in the denser medium such that the angle of refraction in the rarer medium is 90 degrees.
Okay. So let us say rarer medium refractive index is N1, denser medium refractive index is N2. Okay. Now, can you apply this Lenz law for this? Can you apply this Lenz law for this? Yeah, tell me the Lenz law for this.
So can you hear me, sir?
Yeah.
Yes, sir. So it's sine I by sine R is, so sine I by sine C is N, sir.
No. Just apply general formula N2 sine C.
So, okay, so general formula, sir, N2 into sine C is equal to N1 into sine R, which is 90.
That
so
is sine 90. What is sine 90, Appa?
So sine 90 is 1, sir.
So sine C is equal to N1 by
N2, sir.
N2. What is C?
So sine inverse of N1 by N2.
N1 by N2. So this is the critical angle. You got my point?
Yes, sir.
Yeah. One example I will take. Like that. If ray of light passes N1 equals to 2, N2 equals to 1. These are the mediums. Now find critical angle. Find critical angle. Find critical angle for this.
So C will be sine inverse of 2 by, so sine inverse of 1. So sine inverse of 2 by 1, sir.
Sine inverse of 2 by 1.
Yes, sir.
Why 2 by 1?
Sir, it's N1 by N2, right, sir?
Please remember, sine inverse 2 is not defined.
Yes, sir. Sir, sine
Sine
inverse 1 by 2.
always goes from 0 to 1, no?
Yes, sir.
So always this ratio should be less than 1.
Yes, sir.
So please observe here, I had made confusion in this. Now look at this diagram. Ray of light is passing from where to where? Ray of light is passing from where to where in the
So
diagram?
from denser to rarer medium, sir.
Denser to rarer. Then it is always rarer medium refractive index. In the denominator, it should be always denser
Sir,
medium.
denser medium, sir.
So here, don't remember this formula like N1 by N2. You can change that like N2 by N1 or N1 by N2, whatever the symbols you want, you can use it. But please remember, numerator should be always
So smaller than the denominator, sir.
rarer. Denominator must be always
So greater, sir.
denser. So here you have to use N1 by N2 or N2 by N1.
Sir, it should be N2 by N1, sir.
Yeah. So what is sin C then? 2 by 1 or 1 by 2?
So 1 by 2, sir.
So sin C is 1 by 2. That is C is nothing but 30 degree, no?
Yes, sir.
Yeah. So you got an idea, right? Please remember this logic. Always in the critical angle, numerator refractive index should be rarer, denominator should be
Yes, sir.
denser. Now, from this clearly you can tell how the critical angle and refractive index are related.
Sir, they're inversely proportional, sir.
Inversely proportional to refractive index, right? But
Yes, sir.
refractive index is inversely proportional to wavelength, right?
Yes, sir.
So here it is 1 by n. So 1 by n is directly proportional to lambda. Are you getting my point?
Yes, sir.
Yeah, refractive index and wavelength are inversely proportional. Critical angle and refractive index are inversely proportional. Now, you know the concept of spectrum?
Yes, sir.
Vibgaya. This Vibgaya is arranged in the increasing order of what?
So wavelength.
Very good. In the increasing order of wavelength. So what is my conclusion? Wavelength for red color is more compared to the wavelength of violet. Correct? No?
Yes, sir.
Yeah. How wavelength and critical angle are related? How critical angle and wavelength are related?
Sir, they're directly proportional, sir.
So, for which color critical angle is more?
Sir, red.
Very good. So, if you incident red color to get 90-degree angle of refraction, for that critical angle must be very, very large. For which color refractive index is more?
So violet.
Very good. Refractive index of violet is more than the refractive index of the
Sir, red.
red. Correct, no?
Yes, sir.
Yeah. One of the application question also it may be asked upon. What you call, you know the diamond?
Yes, sir.
why the diamond is always going to give a shining property? Why diamond always gives the shining property?
So it's because of critical angle, sir.
Because of critical angle?
Sir, it's because of total internal reflection, sir.
Actually, the critical angle for diamond is what? Have you remembered the critical angle of diamond?
No, sir.
24 degree. 24 degree. Actually, all the diamonds will not give the shining property. A properly cut diamond, a properly cut diamond, properly cut diamond gives the shining property. Properly cut diamond gives the shining property. Why properly cut diamond gives the shining property? Because whenever the diamond is cut, the diamond is going to be cut in such a way that whenever the ray of light is incident on the diamond, it should be incident at an angle greater than the critical angle, in such a way that the diamond is going to be cut. The diamond is going to cut in such a way that whenever the ray of light is incident on the diamond, it should be always incident at an angle more than critical angle. So in such a way that the diamond is going to cut. Whenever the ray of light is incident more than the critical angle, the ray will undergo reflections, no? Because for critical angle, angle of refraction is 90 degree. If you increase this angle more than critical angle, the ray will reflect back. This is called total internal reflection. So whenever the ray of light is incident more than the critical angle, whenever the ray of light is incident more than the critical angle, the ray will undergo
So total internal reflection.
Yeah, total internal reflection will take place. So why properly cut diamond is going to give a shining property? Because the diamond is going to cut in such a way that whenever the ray of light is incident on the diamond, it is incident more than what? Critical angle of the diamond. Because of that more angle, the ray will undergo reflection. That reflected ray will give the shining property. Got it?
Yes, sir.
Yeah. Let me take one more application of this. Let me take one more example of this TIR. That is field of vision of fish. Field of vision of fish. Let me consider the situation like this. This is water. Let us fill this with water. What is the refractive index of this water? Let it be N. Okay. Now, there is a fish here, or you can say some bulb, some source. Now, if I take the ray of light normally, it won't undergo any refraction because of normal incidence. If I take the ray of light, this is the normal. This angle is called the critical angle. The ray will grazes like this. What is the angle of refraction? 90 degree, no?
Yes, sir.
Yeah. Now, this is, let us say something like R, because this fish looks the outside world like a circular path.
Yes,
Because
sir.
the same phenomena can also be explained here also. So this is the circular patch observed on the surface. Now my question is, what is the area of this? What is the area of this circular patch if the height is h? If the height is h, what is the area of the circular patch? Finally, you have to remember the shortcut formula for this. Okay. Yeah. If this is C, can I conclude this is equal to C?
Yes, sir.
Yeah. Now, can you apply what is sin C from this triangle? If you want, you can call this as O. You can call this as A. From this triangle, can you tell me what is sin C? Or you can apply what is tan C also.
So sin C will be.
You go with the tan C first. Tell me what is tan C?
So tan C will be the. So it will be R by H.
H. Tan C can be taken as sin C by cos C, which is equal to R by H.
Yes.
Sin C I'll keep as it is. Cos C can be taken as root of 1 minus sin squared C.
Yes, sir.
You know that sin C is equal to 1 by n because this is rarer medium of air. So this is n. How critical angle and refractive index are related? Inversely, no.
Yes, sir.
Yeah. Now you just substitute sin C as 1 by n and you go on simplify this to get the value of R. After finding R, can't you calculate the area of this patch?
Yes, sir.
Yeah. First you find what is R. This shortcut formula you have to remember. Finally, I think you should get something like h divided by root of n square minus 1. Just cross check it, please. Will you get this or what?
Yes, sir.
You got the same formula?
Yes, sir.
Okay. So if you get the value of R, I think you can find what is the area easily, right? What is the area of the circular patch?
So pi R square.
Pi R square. Area will be equal to pi R squared. That is the value of area. Okay. Look at the second example. There is a water medium here. This is fish. This is fish. Now there is a bird here. This is bird. Okay. Bird is in which medium?
So air, sir.
Air. Fish is in
So water.
water. Now, my first question is, if bird sees the fish, the bird is going to see the fish. What will happen actually?
So the fish,
Appears to be closer, right?
sir, yes, sir. The fish will appear to be closer to the surface of the water, sir,
If
because since it
fish,
is in the,
if fish observes the bird
so the bird will appear to be further away, sir.
further away, because you know that phenomenon in the first page I've written, right?
Yes.
So if the bird sees the fish, it appears to closer. If the fish sees the bird,
So it appears farther.
it will be far away. You got my point?
Yes, sir.
This is also the same thing like that. You know, the temperature is also going to affect the refractive index. Temperature also affect the
So refractive index.
please remember, as temperature increases, its refractive index will decrease.
So decrease, sir.
Yeah, refractive index will decrease because of more heat. Because of more heat, the particles will get evaporated. The particles will get absorbed. When particle get absorbed, it becomes a rarer medium. So it has to become less refractive index. So critical angle should be increases.
Yes, sir.
So please remember this also. As temperature increases, refractive index will decreases, but the critical angle will
So increase, sir.
increases. Yeah. Now, this is the earth. This is the earth. Now the sun is here. You know, this is the origin. This is the origin. Now this is the sun. This is the earth. There is an observer here on the surface of the earth. Observer is on the earth. Okay.
Yes, sir.
Now, during the sunrise, now the sun is not at all actually raised actually. Sun is not still rise. Actually, before the sunrise only we can see the sun. Why? Sun is not above the origin actually. But whenever the ray of light is incident from the sun, it will undergo the refraction. Because of that refraction, we are getting the virtual image of the sun here. The virtual image of the sun here. Actually, sun is below the origin only. Are you getting my point?
Yes, sir.
Actually, before sunrise only, we are going to see the sun. Because when sun is close to origin, because of the atmospheric refraction, because of what? Because of
So
atmospheric
atmospheric
refraction.
refraction, sir.
Because of atmospheric refraction, we can get the virtual image of the sun 2 minutes before actually. Actual sunrise ಏನಾಗುತ್ತೋ ಅದಕ್ಕೆ 2 minutes before only we can see the sun because of the atmospheric refraction. Now, during sunset also, actually sunset is done. Sunset is also got over. But before sunset, I mean after sunset also we can see the sun. After sunset also we can see the sun for 2 more minutes. For 2 more
Minutes, sir.
minutes because of atmospheric refraction. Actually sunset is got over. After sunset also we can still see the sun for 2 minutes. Why it is so?
So again, because of atmospheric refraction, sir.
Because of atmospheric refraction it is taking place. So for 1 mark reasoning question also they may put the question, why there is a advanced sunrise and delay in the sunset? Why there is a delay in the sunset and advance in the sunrise?
So because of atmospheric refraction.
So totally how much time is longer in a day?
Sir, 4 minutes, sir. At the
So
sunrise.
actually
2
4
minutes
minutes
at
is a
sunrise.
longer.
Yes, sir.
So 1 day 4 minutes longer. Like that, if you calculate for 1 year how much, for 2 years how much, for 3 years how much, for 4 years how much, you can calculate all those things.
Yes, sir.
Okay, they may ask the problem based on related to this also. They may ask the question related to this. Got it?
Yes, sir.
No doubt?
Yes, sir.
Okay. Now the last concept is the another this thing, that is reflecting prism. Reflecting prism. Actually, reflecting prism is a isosceles right angle. Isosceles right angle triangle. It is isosceles right angle triangle. Now, for example, if I say this is a right angle triangle with isosceles. Isosceles means these two distances are. Equal, no?
Yes, sir.
Yeah. Look at this. Now I'm going to keep the object here. This is A, this is B. AB is the object. AB is the object. If I send the ray of light, here it will be incident more than the critical angle of this glass. So it will bend like this. It will undergo refraction. For A, it is like this, the dotted line one. So the image of A is formed here. The image of B is formed here. So if the object is from A to B, here the object is from A dash to B dash, right?
Yes, sir.
This is object. This is image. Take up the second case. Take up the second case. Second case is like this. Second case is like this. This is hypotenuse. 90 degree. Or do one thing. Let me write like this. This is equal to 90 degree. Now I am going to pass the object here. This is one ray. This is A, this is B. Here this A will undergo refraction. Here also the A will undergo refraction. So this is the image of which object? A dash. A ray will go like this. It will undergo reflection. It will undergo reflection. It forms a dash. Tell me for B. Correct?
Yes, sir.
This is B. This is B. It will undergo
Sir.
one more.
Total internal reflection.
This is B dash.
Yes, sir.
So this is A dash B dash image. So
Yes.
this is object. This is
Image, sir.
image. Now, can you tell me the difference between the first diagram and the second diagram? Look at the difference and tell me that. See here, the object is vertical, right?
Yes, sir.
Here the image is.
So horizontal.
So this is object. This is image. It is turned by what angle?
So 90 degrees.
Very good. Look at the second one. AB is the object. Image is in this direction. What is the angle between this?
So 180.
So in the first case, the image is turned by what angle?
So 90
degree.
degrees.
In the second case, the image is turned by what angle?
180 degrees, sir.
180 degree. So to turn the object either by 90 degree or by 180 degree, we are using a device which we call it as reflecting prism. This reflecting prism works on which principle? Works on which principle?
So total internal reflection.
Total internal reflection. So this is the concept related to what?
So reflecting prism.
Total internal reflection.
Reflection, sir.
So what are the three concepts we have studied up actually? First thing we have studied refraction, right? In this refraction, we have analyzed the three concepts. One is lateral shift. Second one is normal shift. The third one is total internal
reflection, sir.
reflection. So these are the three important concepts, Appa. If you have remember all the formulas and the concepts, in the next class, I will take the MCQs of these three concepts. We'll solve some numericals based on lateral shift, based on basic refraction phenomena, normal shift, and the total internal reflection. That we can take up in the next session. Okay.
Yes, sir.
You have any doubt or any questions from this today's topic?
No, sir.
Yeah. Please you study for the next class. Before coming to the next class, if you remember all these formulas, so that I can solve the problems based on this. Okay.
Yes, sir.
Yeah, okay. Thank you. Let me continue in the next class. Okay.
Yes, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.